streaming. Just have to make some changes. Hmm. Hmm. Okay. Okay, I'm just gonna add the problem numbers that we'll be solving right now. 78, 79, 80, 81, 82. Okay. नहीं.
नहीं ना, मैं बोलने में लगा ही नहीं जितनी कभी छोले कुलचे खा के आया है। नहीं, हाँ।
Okay, cool. We are here now. My internet connection is really bad right now. Awesome. Okay. Hmm. Okay. Okay, I guess we'll just bring it to top when necessary. Alright, let's start with this problem subsets. It says given a set of distinct integers, return all possible subsets. So basically, to the power n results. So this looks fairly simple. Um, oh, I will show you what approach we are taking. Um, so we saw how to take subsets starting from an index. So basically, let's take the given example of 1, 2. Sorry, this is a makeshift stylus, so gonna have to bear with me a bit. 2, 3. So say uh, obviously one set would be picking no elements, but apart from that, it would be starting from the first item and um, iterating over all the items and picking or not picking uh, an item for a iteration. So we start with one. This is the for loop, and each call would go into our recursive function. Basically, my iPad does not work over here. Uh, Wait, oh, that's the Notes app doesn't have anything over there. Yeah, I might as well use my finger. So for one, um, For 1, we go into our recursive function where the for loop is written, and where is it written outside? No, it's written inside the recursive function. Yeah, and then we push 2, uh, and we again make a call to a recursive function where we push 3, and then we come back out to here, then we skip 3. Um, Sorry, when do we skip 3? Oh, basically we're not skipping anything anytime. We are just going to be every time we are iterating, whatever our item in the sub in our set is, we add that to a result. So basically on the first iteration you have 1, you add it in a result. For 1 we have 2 iterations, this and this. For this iteration we add 2 and we add it to a result. Then for 2 we have 1 iteration which is 3. Um, we add 3 and add that to a result. Then we pop 3, we go back here. Uh, the iterations are over, so we go back to 1. And then for 1, the next iteration was 3, so we push 3. So now we have 1, 3, so we push that in our result as well. Um, so then this iteration is over, so we go out to our last iteration, which is the first iteration. We start with 2. Similarly, for 2, we add 2, and then for 2, we have 3 as an iteration, so we add 2, 3. Then for 2, our iterations are over, then we add just 3, and for 3, there are no iterations, so we've added, when we started, we added 1, then we added 1, 2, then we added 1, 2, 3, then we added 1, 3, then we added 2, then we added 2, 3, then we added 3, and we add blank manually, uh, I guess, and that's it. That's all that's required. Okay, I'm having a little shitty bit of internet, so I'm sorry for the delays, Penny. Um, so we have that, and let's try and code that out. Yeah, okay. So we'll be having our helper function. We'll be having a value that we are returning passed into the helper function. We will have a be passing our array. We will be passing our starting index for the for loop, and okay, that's all I can think of for now. Let's do that. This is our response. This is our input, and this is our index, beginning index. So you pass this by reference. Okay. So now if, oh, and I guess we have our current path that we want to push also. So here we'll just pass a blank vector, and if path dot empty. Yeah. So if not path dot empty, then result dot push back path. Okay. So for int I equals beginning, sorry about that, I is less than input dot size I plus plus path dot push dot pushback input I. Then you call helper with I plus 1 current path value nums, and then you pop back, and that's it. And then you return your value. Oh, sorry, we also have to push a blank item. Helper with no type. We also need to push this. Doesn't say anything about the order. Ret was not response, so it's a response actually. Nums was not declared, so it is the input actually. Seems good. We might have also handled nums being empty. Yeah, so this was pretty straightforward. It's not, I don't think it's even worth of being medium. It's straightforward backtracking with no conditions as such. Let's see the solution. Oh, it does. So this is on times 2 to the power n and with 2 to the power n. Okay, what's this thing? The idea was, the idea is that we map each subset to a bit mask of length n, where 1 is on the ith position of the bit mask, means the presence of the number in the subset, 0 means the absence. Oh, that's pretty cool. For instance, 0, 0, 0, 0 corresponds to an empty subset, and 1, 1, 1 means all the answers. Wow. Holy moly. So what they did was take every item in the set and create a array, create a set of strings that correspond, that have like either a single one or either no ones or single one at any position, or two ones all combinations, or three ones all combinations, and basically that can be converted from a number. So you can convert the number 1, 2, 3, 4, 5, 6, all those numbers, and those are actually the combin, and they have all the positions of ones and zeros and all the combinations from length, you know. whatever is the length of a number in bits, which I guess is this much. And then if it's a 1, you in your current path you add that number in your current vector, otherwise you don't, and you add that in your answer in the end. That's also a smart thing to do, man. Anyway, I guess it shows the same complexity, space time. Um, I think their solution was checking the size is k. What is k? Yeah, you don't need to check. You just need to check if it's not empty and just push it. If you're using the for loop, then I don't know why it's necessary to do that. Oh, they did one outer and then one inner. Yeah, that's why I guess. You can just do this one, it'll do it for all the cases. Great, subset done. Word search, 33%. Not downvoted. Okay. Given a 2D board, find if the word exists in the grid. The word can be constructed from sequentially adjusted cells, where adjacent means those that are horizontally or vertically neighboring the same letter. Cells may not be used more than once. The word A, B, C, C, E, D returns true. A, B, C, C, E, D. A, B, C, D. A, B, C, B. Okay. Hmm. So you have a board and a word. So whenever you find a character, okay, let me write that down again. It would show better if I write it down. Is there a way to clean the board or something? Anyway, I'll let the dots be. Okay. So if you want, I can set to full screen. Well, that's not doing a great job of being full screen. So I guess let's let it be here. Um. Okay. So yeah, so saying, so you have your board here with some characters. Anything, I'm just putting anything. So your first job would be to obviously find your first character. So which character you're looking for? Let's keep so this say is our string. Yeah, we keep an index, that is which index of the string we are looking for. So we start this with 0. Um, we can just linearly search in our board. When we find that character, say it was here, we can just pop it, save it somewhere, and pop it, and then send the remaining board to look for this string and index plus 1. Uh, from where? it will be uh, and we'll pass this index, this I and j, so that we can only look here, 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 and here. Every time we do find an answer, do find a point. So we'll try all four, and when we do find a point, we'll recursively call our recursive function on that point. Uh, Again, index plus one, I and j updated, and we'll obviously have to remove this while calling the recursive function, and when it comes back, we'll be adding our character back. Pretty dirty, but let's see if this logic will work correctly or not. So finding the first character is outside the recursion because it's a different logic, because you're not looking for there's no conditions. My J key is sort of broken, I guess. Now this will not work for a 2D board which has just one length, maybe, or will it? It will. Sorry, it will. Um. So if um board I j equals word 0, not gonna pass anything by reference. All so we call the helper function. So let's say it's word 0, so we already know, so we don't really need to save the number, save the word. So we can just set board I j equals blank, and yeah, so just pass the board, pass the word, pass which index you're looking for, um, pass the I and j that you are on right now. So that's I and j. Um, I think that's probably it. That's all that we would require. Okay, word, index. Okay, so now that we know all this, what we can do is if so to check left, if there exists an item in the left, we have to check if I is greater than 0. Then if board I minus 1 j, sorry, this is j not I, j is greater than 0, then same row j minus 1. So let's just comment which character we're looking at. So this is left is equal to word index. Uh, do if index equals uh, I think we'll have to keep a flag that will be our answer. Hmm. Yeah. Okay. If index equals word dot size, which means you're at the end, so just flag equals true and return. Alright, so now if j is greater than 0 and the left one matches, then we call the helper function again with the same inputs, except flag, we moved one position to the left and we need to update this item. So um, char temp is this is temp, and we just clear this out also. Okay, now we have to do the same for a lot of conditions. So now if j is positive, also if j is less than b board 0 dot size mm, minus 1, which means it's not on the edge. So this is checking for the right. So now you move one to the right, right? Now let's check up. So now, which means to go up, I must be greater than 0, and we'll be going minus 1 in I. Yeah. Oh, sorry, we have to pass index plus 1 in all these cases. And for down, we have I less than board dot size, then minus 1, then we can go down. This will be plus 1, plus 1, plus 1. I think I made a mistake here. Plus 1 and plus 1. Okay, to me this looks absolutely correct. Or else we just return. Um, oh, sorry, it does return on its own, so we don't need to write anything, of course. We are increasing index, we are resetting the board, we are updating flag, empty character constant. Okay, so we can just set it to blank for now. And here as well. Okay. We can also add a condition after this if to check if the result is already true, then we can just exit. Uh, okay, comp error, it's fine. I minus j plus j minus, okay, looks good. Unknown address access. Okay, really hard to judge where it would have happened. Oh, I could have just written word index here. Here, not here. Hmm. Guess we're gonna have to debug it. What is our test case? A, B, C, C, E, D. Okay, it's the first one. So since the first character matches, it'll go inside this if, then it'll go inside the helper. So we're not going left, but we are going right. And since it matches, awesome. Then we go in again. Then we'll be going right again. First we check left check fails. We go right, right check passes. Then we go in again. Then we check left check fails. We check right, right check fails. We check up, we can't go up. We check bottom check passes. So now we've already got A, B, C. Now this is the next C. Um, we go in again. One check fails, two check fails, up check fails, bottom check, bottom character matches, passed, A, B, C, C, E, D. So we're gonna hit bottom again. Oh, hmm. Which means the last one. Okay, so I'm probably failing when it's going left. So let's put a breakpoint here and see. Index would be 0, 1, 2, 3, 4 or 5, 0, 1, 2, 3, 4, 5. Yeah, 5. It matches with D. We go check. Index is now 6, and word dot size is also 6. Flag should be set to true. We return. We reset this. Check other sides. Then we check other sides everywhere. So on and so forth. We're going down, right? Yeah, so this is the code for down. Uh, is I less than this? It was 4. I was 3. It would pass, so we could still go down. No, that's not possible. Saying check for right. No, 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 that's definitely not true. If flag return. So we don't need to check for anything. And we'll put that over here as well. If result return result. I can't find the out of index bound access was because of this and this only. Yeah. A B output true expected false. Hmm. So can you go anywhere? Hmm. There's an issue in this condition. We are at index 1. How's this working? Says it so what it's looking for is it starts with the oh it's oh no wait what it's index plus 1 not plus plus. This failed. So our index is 1. Now you can't go right or left or anywhere for that matter. Why is I 1? How did I become 1? Hmm. It has one row and first row has one column, right? Hmm. Yeah, so I is 0. No breakpoints here. Oh, I'm doing I plus plus here. So it was only wrong, guys, because I'm retarded. So just go to J plus plus here, and let's just submit. You guys should be telling me this if you watch the stream. I'd know, you know. Output false, expected true. C A B C D and A B. So it's huh, looks fine. I mean, according to my logic. So we debug. I think it's gonna start for I0 and J1. The board is fresh. Step into. Will this find AAB? Uh, okay, nobody's finding AAB, right? So we can AAB. So we'll actually find it at 1 1 is when we should even look. Yeah. So 1 1 is this one, center one. This goes left and then goes down, so we find AAB. So we step into this. Now, when the left one matches, what? That makes no sense. Okay, we step into this, step into this. I and J are 1. Is I greater than 0? That's correct. Is the left number same as the index? What is the index right now? 1. Is it same as AA? It should be. How is it not? Oh, they're blanks? Why? Why are they blanks? Oh, because I'm not resetting them. My bad. I thought of this, but I forgot to do it. Actually, equals word 0. leetcode should work fine. Submit. Okay. Oh, I'm sorry. I covered the code the entire time, so I weren't able to look. Okay, my bad. Didn't want to cover the question actually. So it's quite slow relatively. Um, let's look at the discussions. Sorry. Oops. Very short solution, no additional space. 19 ms accepted code. So essentially what they did was yeah, so they did DFS. So yeah, so this is find the first character and then if I guess it's the same thing. Okay. Remove duplicates from sorted array number 2. So how I did it last time was, let me bring this up and let me clear the board. Let me know if you guys know of a better note-taking app. I'm just using the notes on my iPad. I'm using something called Let's View to cast it. And I'm just using my finger as a stylus for now. Okay. Hello, the one viewer that I have. Hope it's not me or the mod being considered as a viewer. Okay, so oops. Hmm. So what do we do now? Yeah, so the last time what we did was in a sorted arrays it was like 1 1 2 2 3 3 3 4 whatever. So what you do is you keep one pointer and another pointer and you move the second pointer till you don't find a match. So you come here, these are not matches. It's like the your car this second pointer and the previous one is not a match. So you take this value and set it on the next pointer here and then you update this pointer to point over here, and then you keep moving this pointer till this value matches this value basically, or the previous value. And when it doesn't, you update this pointer ahead and set the value here. So it becomes 1, 2, 3, 4. Then you get the size as per where this index is pointing. So this index plus 1 is the size. If they match, then you can just if they match, then you can update. What is it? Remove duplicates, right? Yeah. It's gonna have one copy of it anyway. Yeah, correct. Okay. So that was remove duplicates 1. Let's see what 2 is asking us to check. Um, Given a sorted array nouns, remove the duplicates in place so that duplicates appeared at most twice and return the new length. So, okay, you have to modify it in place. So it's not a very highly upvoted question, so it's probably very similar to remove duplicates 1. It's not a useful use case, I think, that I can see of this question in a real life scenario as well, is why it's not an appraised question. So I guess all you need to do is use the first when you're checking for a number. You can just add a flag as to whether it's the first time you're seeing it or the second time. And when you're seeing it for the second time, that's when you start incrementing the other pointer till you find the other number. Then you set it to the second index. Then you set it ne next to your current index, and then check for that number twice. And if it's there, then you copy it to the next index of your current index and set the flag, and then look for the next number. So it's this really seems like an unnecessary sort of hmm. So for the items in number, if I is less than 2, or if the number is, let's go through the numbers, include those in the result that haven't been included twice already. Okay, so I is 0, then I is 1, I is 2. So include the first two numbers directly. Then you check if the number that you're checking right now, is it less than, is it greater than the number that you added two steps back? Then, which means it's different from the number that you added two steps back. Let me try and make visualize this for you guys. So this is 1, 1, 2, 2, 3, 4, 4. So there's an iterator that starts at 0. Now if this is less than 2, then we just push the first two characters basically, because they're obviously not going to be affected by our goal. Sorry. Now this becomes 1, then it becomes 2. Now if it's not less than 2, so basically it's here. So what you check is if the number at this place, yeah, is so you have another iterator actually that's just going through the items. Let's call it like this. So it's here. You check if this number is greater than what you had two steps back. Basically not equal to what you had two steps back from your final result, which is this one. Which is this one. Um, which means that it was either the last number, this one, or it's coming for the first time, like so, like it is. If it doesn't match with two steps back, so you just push it to your result. How is that you update this item? Uh, let's take a valid case. You update this item that your eye is on with your value that you're looking at from the iteration. Now you're looking at the next value, your eye is also incremented. Now you see if this value, this 2, is is greater than what was there in your result two steps back. So which was 1. So you add this 2 as well. Now your uh, iterator goes here and your I becomes 4, which means you're waiting to fill the fourth space. Well, the index starts from 0. So now if yeah, so now we check if the item that you're trying to fill right now, which is this 2, is greater than what was 2 indices before this 4. So you check this and you check this is 2 itself, which means that 2 insertions ago we already had a 2, so you don't insert this 2 anymore. So you just skip to the next number. Here I is 4 because I is not the iterator here. I is the space that you want to fill. Your iterator is just this top black bar, dark black bar that I'm showing. This is your iterator. So now we're at 4. We check if 4 is greater than what was at fourth index minus 2, which was this one. It is, so add 2, which means 4 was either added here, which will be true for this case, which also will be added. So 4 was either added here or mm, not added yet. So for this 4, it was not added here, and uh, if it was a duplicate, which means this there would have been 4. If it was the third occurrence of 4, the 4 would have already been here at this 2. So since yeah, that's a pretty smart way of doing it. What was I thinking? Of two iterators, same thing, and I was updating the value of one of the iterators with the value that was at by comparing two items at a time. So he's comparing our result, and I was comparing with the flag. So yeah, that flag is not necessary. This is such a short and elegant answer. I think you should try and remember this. Um, hmm?